Hi guys, 9-1, adding and subtracting polynomials. Now we're really getting into some good, strong algebra stuff. Um, First thing that we want to do is to talk about some of the terminology. Monomial is an expression that is a number, variable, or a product of a number or one or more variables. Each of the following below is a monomial. Okay, so 12, which is a constant, y, negative 5x squared y, and c over 3. Now, c over 3 is a monomial, but c over x is not because there is a variable in the denominator. So you cannot have a variable in your denominator in order for it to be a monomial. Okay, the degree of a monomial is the sum of the exponents of its variables. For a non-zero constant, the degree is 0. 0 has no degree. So 12 would be degree 0. Y would be degree 1 because that 1 is implied. The degree of this monomial would be 2 plus 1, which is 3. And then c to the first of 1. All right, let's go ahead and do this. Okay, whoops, did not mean to do that. Find the degree of each monomial. All right, so as we just said on the previous slide, that if it is a constant, its degree is always going to be 0. And that's because it could be 18 times x, but in order for that to be equal to 18, then that would be x to the 0, because then this would be equal to 1, 18 times 1, right? So degree 0, that's where that's coming from. This one down here, the degree would be equal to this 1 plus 3, which is 4. And this one down here, that's degree 1, so degree 1. And that's it. All right, so when you're finding the degree, it's just the sum of the variables. And if there is no variable, then it is degree 0. If it's just a constant, it's 0. Okay. Whoops. Technology is not my friend. Okay, taking a look at this, a polynomial is a monomial or the sum or difference of two or more. The degree, in order to have it in standard form, the degrees must be decreasing, right? So the largest degree comes first, then the next, the next, the next, and so on. Okay, take a look at this chart. These are the different polynomials. This is going to be what it is based upon the degree, and this is what it is based upon the number of terms. So 7x plus 4, that's degree 1, and because that's its largest, the degree of the polynomial is equal to the largest degree of that particular polynomial. That's a linear because it's degree 1. 1 is linear. 2 terms, so it's binomial. This one, its degree is 2, which is quadratic. And there's 1, 2, 3 terms. That's a trinomial. This degree is 3, which is also known as cubic. There is 1 term, so it's a monomial. 9x to the 4th plus 11x, so that's going to be 4th degree. And anything 4 or greater is just that number degree. 5th degree, 6th degree, 7th degree, so on. There's 2 terms, so that makes it a binomial. 5 is a constant, so it has a degree of 0. 1 term, so it's a monomial. You're going to need to classify the polynomials based upon the degree and the number of terms, and you're going to need to use these official algebraic words. Okay, you can't just say degree 1. You're going to have to say linear. Can't say degree 2, quadratic. You have to use the actual proper language. Okay. Now, let's take a look at this example. Write each polynomial in standard form, then name each polynomial by its degree and the number of its terms. Okay, so looking at A, this would be degree 1, and this would be degree 0 because there's no variable, it's a constant. So that means we need to rewrite this so that it is 7x minus 2. Now there's two terms, right? It's degree 1. So because it's degree 1, and then there's terms, two of them, we know this is going to be a linear binomial. And that's what you would need to have, okay? This kind of just helps you determine what you need, but you have to have this linear binomial. Looking at b down here, let's see, 3x to the 5th, that is degree 5, minus 2, that's degree 0, 2x to the 5th, that's degree 5, and 7x is degree 1. Well, I need to do something about these two because they are like terms, right? They both have x to the 5th. So 3x to the 5th minus 2x to the 5th is just going to be 1x to the 5th. And then that is taken care of now. We have 7x, and then we have minus 2. All right, so the degree is 5, so this would be 5th degree since it's greater than 3. And there's 1, 2, 3, so it is a trinomial. So this is a 5th degree trinomial. All right, let's take a look at the quick check ones because I want to make sure you guys have really got this. At least putting it in standard form is the main thing, but classifying them is also very important for this particular part, and it's easy. Okay, so this would be degree 2, degree 0, degree 4. So we're going to put this one first, and that's negative 9x to the 4th. It's a positive 6x squared, and then plus 7. Degree 4, degree 2, degree 0. So this is 4th degree, and there's 3 terms, so it's a trinomial. All right. 3y minus 4 minus y cubed, degree 1, degree 0, degree 3. So putting this in order, we have negative y cubed plus 3y minus 4 because those signs stay with that particular term. All right, 3rd degree, so that's going to be a cubic. There's 1, 2, 3, so it's a cubic trinomial. And finally, this one here, 0, 1, and 1, which then means I can combine these two, 7b minus 11b. That's going to give me 8 minus 4b, so that's 0 and 1. So this needs to come first, negative 4b plus 8. So that's a degree of 1, which we know is linear, and there's 1, 2, so this is a binomial. All right. Okay, hopefully all 4 of those examples, or 5 examples actually, help you understand the classification and putting them in standard form. All right, so let's go on to example 3. Adding polynomials. All right, so we are going to simplify these. Now, when I was learning Algebra 1, this is how I did it. I did it horizontally. As a teacher, I see some validity, I see some importance, I see some really cool aspects as to why you would add them vertically. Over here, you have to pair up your like terms. Here, they're already matched up. If you write it properly, you like terms in the same column, and then you can just add, subtract as you go. All right, so we're going to try vertically on one of them, and then we'll do, if need be, we'll do the other one horizontally. All right, so we've got 6x squared plus 3x plus 7. And that's degree 2, 1, 0, so we know it's in standard form, plus, so that's not going to change anything, 2x squared minus 6x, and then minus 4. All right, so we have 6x squared plus 2x squared, 8x squared. 3x minus 6x is minus 3x. 7 minus 4 is 3. So 6x squared plus 3x plus 7 plus 2x squared minus 6x minus 4 will give us 8x squared minus 3x plus 3. And that's it. Yay! All right, now if we were looking at doing them horizontally, let's do C. So that's going to be 9w cubed plus 8w squared plus 7w cubed plus 4. I removed the parentheses since we were just adding, and we don't need them. It's not necessary. We want to combine like terms, 9w cubed, 7w cubed, 8w squared, and 4. Now, what I just did was I grouped up my like terms based upon the shapes. I call this the shape method. So the terms with degree 3 are both in squares. Then that was it. So now I went to a different shape, and this one was circles. That was the only squared. And then I went to a third shape, which was for the 4. So adding these two together will give us 16w cubed plus, let's see, that's done. Now, which one comes first, 8w squared or 4? You're right, 8w squared, and then plus 4. And that's it. So that was doing, adding it horizontally as opposed to vertically. The main key there is to make sure you line up like terms, okay? All right. Now, subtracting. Subtracting is harder for one reason and one reason only. We have to remember we're subtracting. So either we need to distribute that negative, or we need to write it and just remember that we are subtracting. I would always just write it, take the opposite sign, and then just add them together, because adding the opposite is the same as subtracting. All right, let's go ahead and do it. All right, so I'm going to write this first one without the parentheses. 2x cubed plus 4x squared minus 6. I'm going to distribute that negative. Negative 5x cubed minus 2x, and then plus 2. And if you notice, that's the opposite sign, because that was positive, positive, negative. Now it's negative, negative, positive. 2x cubed and negative 5x cubed are like terms. Then we have 4x squared. That's the only square. We have negative 2x. And then we have constants. All right. So the cubed is the largest. So 2x cubed minus 5x cubed is going to be negative 3x cubed, right? Because 2 minus 5 is negative 3. Those cancel out. Now we're looking for the next largest degree, degree 2. It's the only one, 4x squared. Then we go through, next is degree 1, this minus 2x. And then we have negative 6 and positive 2. Negative 6 plus 2 would give us negative 4. And that's your answer. Now, I'm going to do this one also vertically, just so you see. We have 2x cubed plus 4x squared. We do not have an x term, so I'm going to leave a gap, and then we put minus 6. And then we have minus 5x cubed plus 2x. So I don't have a term here, so I'm going to put plus 2x and then minus 2. All right, so 2x cubed minus 5x cubed, negative 3x cubed. 4x squared minus 0 is just 4x squared. 0 minus 2x would give us negative 2x. And negative 6 minus a negative 2. Minus negative makes positive, so negative 6 plus 2 is negative 4. If you notice, these are the exact same equations. They were just two different approaches on how you would solve them. Okay? All right, let's see. Whoops, not that one. Example Oh, that's it. I was thinking there was 5. All right, well, that concludes this particular section, and we'll talk to you later.